hit. So, why bother evading? Why bother evading if I'm just gonna get hit? Cool, double fucking hit. Let's go. You poor fucking bastard. Jesus Christ. Thank you.
Here, Pep.
Oh, I healed.
Are you
Good.
full?
Yeah, good. Oh my god.
Yeah, I'm gonna rebuild this camp real quick and restock.
Good.
I have to wait 40 seconds. Oh, hell. Come on, game. On the way.
There's a wound on his back I can't get to. Oh wait, maybe I got it? I don't know. Did you get it? Wait. Trying to get him to come to the trap, watch out.
He ain't gonna come. He's getting ready to dip.
He's exhausted right now. Did you get it? Okay.
Yeah, I got the wound.
Yeah.
There's another one on his right chain.
Oh my god, that would hit me for that much damage. Oh my god.
Oh, got his tail.
Nice, nice. Poor little guy. Flew into the wrong motherfucking neighborhood.
All right, I'm gonna go back again.
I have a camp, or keyword, had a camp up where he's going. I'm gonna tell you to the main town, get it set up. Since my camp down there got fucking demolished. I'm just gonna restock at that camp. Oh, camp master. We got a sale on. How can I assist? Conut, I would like my... I can't manage my pop-up camps from here. Fuck. I can't that's so stupid, dude. Come on. I probably should have reloaded, but whatever. Dung. Dung, dung, dung.
I gathered some materials too. Check your field pouch.
You don't
Hold on,
notice
I'm
me.
gonna. Or do you wanna?
I was
yeah,
just gonna
you
yoink
do
the
you.
wall down on him.
Do it.
Go. And he's almost dead. Fuck. Triple arc failed scales. I need the fucking chain blades to burst, man. I beat the shit out of those things and they just do not break. I'm pretty sure that was mostly all that I hit on him that whole fucking time. I might have got a headshot or two in there, but like...
All right.
This thing's a trouble.
These fucking things just don't break. God damn. Oh, look at that. It's beat my meter clock. That's funny. That time already? Oh, shit, man. Hell, Schmitty, I mean, it's afternoon for you. It's definitely beat Joe Schmidt o'clock. I'm level 80. Once I get to ancients and need to go level, maybe. Once I get to ancients and need to go. You got to be level 60 to do Hell Ancients. So if you're not getting power leveled in Hell Chaos, if you're over level 24, then
Yep.
I mean, Hell Chaos is going to be the best place for you to level anyways, but you're 50? Yeah, you're going to go level. You got to go level for a little bit. Hello, hello. I'm not where I'm supposed to be. Don't you help me sober up. I don't think I ever looked at the Gypseros's armor. What the fuck am I looking at? I am penis incarnate. And then dress. Your cell armor looks cool. That's what you think a penis looks like? You might want to go fuck your own face. Oh, wait, what does this give? Forager's luck. Heroics, Geologist, and Max Might. Do these boots just give a 3 to Geologist? That's crazy. I'd be intrigued to make those boots instead. All right, that was gonna be my last time, but I want to go see something real quick. My favorite color is you and I. Are you laying an egg? What's with the crotch bulge? That's funny. It looked at me. Your fatherless behavior. Get a job. Damn. Who hurt you?
Alright.
Oh my god.
You calling it there, I assume.
Hey, yeah. God damn. Where's my wounds at? Ah, there it is. That's crazy. Zero sum discharge finisher. Just like what I did to your mom last night in the fucking pool. God damn. Oh god, chat. I'm gonna wake up. If you guys see me struggling in bed, call the ambulance. Fucking oh my.
We need an Addy.
Dude. A what?
We need an address to send them to.
Oh, an Addy. You don't have my address?
No.
I think Mehammer does. He sent me my chair. So, if anything, get him on the line.
Get him on the line.
Oh my god, my fucking like I said, I moved in ways I didn't think I could move, and my legs got so. I did more deadlifts than I've done in a long time, though. Oh, make sure I'm not like inflamed or bleeding or bloated or anything like
All right. I do, however, think I'm gonna go do dishes because I have to go do dishes.
that. Well, you go be productive. I'm gonna go get some sleep. Oh baby.
Yeah.
But yeah, I'm gonna be doing well with my pots tonight, but I might do Monster Hunter before he wakes up. I don't know. We'll see. Because I think we might be falling asleep at the same time, and I don't know if they have this night off together. So if they do, then I might be on Monster Hunter. I don't know. Figure it out. But you have a good rest of your day, sir. I'll probably see you later tonight.
Yeah, maybe. I don't know because I never did fall back asleep this morning. I tried and I couldn't.
You're getting the what, like 4 to 6 hours of sleep?
Um Not even last night.
Well, if you end up passing out, I won't hold it against you. I got plenty of stuff I can work on in WoW, and I'd just be grinding to monster level 100 anyways, or hunter level 100 anyways, so. Oh.
Somebody's already hit max monster hunter level
Oh, I bet.
or hunter rank.
I bet.
999.
999. That's what happens when you get efficient at killing the hardest thing in the game that awards the most experience, and you just do that over and over and over again.
It's
and multi-hunt.
It's a dual fight.
Yeah, you have to fight two to get the most per.
The Gravios and Ajarkan.
Ajarkan, eh? The Ajbjorken?
Yeah. It was a full squad, 3 heavy guns, 1 light. Right? Yeah. And dude, they obliterated the both of them in about 2 minutes.
2 to 4 minutes, yeah. Ajorken, eh? Yeah, Ajorken. The Ajorken. It's scary. Ajorken. Bork. Oh, my left nut. Oh, hey, chill, calm down. My balls are gonna explode, chat. And not in the fun way. Oh. Ooh. 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 Okay. I gotta go fucking brush my teeth and take care of some shit before I lay down, chat. Jocko.
Have a good sleep.
You have a good day. If you pass out for a nap, I hope you get good rest, but we'll see how that goes.
Okay.
But thanks for hanging out with me this morning, man.
Yes, sir.
Oh, peace, baby.
Bye.
Oh my god, Choco's my favorite. I like sucking on his titties. I mean, I didn't say that out loud. You're weird. Chat, you know the deal. Going to bed, getting some rest. I'll see you mother truckers when I wake up. I'm gonna catch a shower when I get up, and all that jazz. We'll see. Also depends on how fucking much I sleep, but oh, you guys have a good one. Take care of yourselves. Be safe. I'll see you goofy goobers in a little bit. And yeah, we'll have a lovely evening tonight. Probably doing WoW with Gordy, so come hang out and goof off with us. Totally just depends on what his plans are tonight and all that jazz. So I'll see you guys when we arise. Don't burn the place down while I'm gone. Enjoy the space stuff. Peace, guys.
The simplest of these compounds is quartz, but scientists have also found more complex substances. These compounds are thought to form large clouds in the brown. However, it is still much warmer than the gas giants in our solar system, even though it doesn't have a star to heat it. What's surprising is that the outer layers of this brown dwarf contain not only typical components like water, methane, and carbon dioxide, but also tiny particles of various silicon compounds. The simplest of these compounds is quartz, but scientists have also found more complex substances. These compounds are thought to form large clouds in the brown dwarf's atmosphere. Scientists had predicted the presence of these silicon-based clouds based on theoretical ideas, since silicon is common in the universe as a byproduct of stellar reactions. However, it wasn't until recently that observations confirmed this hypothesis. Around 140 million years ago, the system might have been a single cloud of gas and dust, which later split into 3 separate clumps. This splitting might have been caused by the gravitational pull of a massive object that passed too close to the cloud. Interestingly, if the splitting hadn't happened, the total mass of the resulting object would have been enough to start a self-sustaining nuclear reaction. In that case, instead of 3 brown dwarfs, we might have ended up with a small star. The James Webb Space Telescope, with its powerful equipment, is not only capable of observing distant objects in space, but can also capture enormous structures stretching across hundreds of light years. One such structure is the Carina Nebula, one of the largest stellar nurseries in our galaxy. Located about 8,500 light-years from Earth, the Carina Nebula has a mass up to 900,000 times that of our Sun. It contains massive clouds of gas and dust, as well as thousands of stars, ranging from the smallest to the largest. This nebula is home to 2 of the Milky Way's brightest stars, Ia Carinae and W25, which shine millions of times brighter than the Sun. Objects like these always grab the attention of astronomers. James Webb's infrared cameras can also peer through the dusty haze of the nebula, revealing many stars that were previously unknown to us. This area of space is teeming with hundreds of young stars, which are constantly being born. Modern theories suggest that new stars form when gravitational forces compress and heat clouds of cosmic dust. As these clouds evolve, a protostar forms and goes through several stages before it finally starts nuclear reactions in its core. While this theory is supported by many observations, there are still many details of this long and complex process that scientists are working to understand. The formation of a new star can take millions of years, but thanks to the infrared capabilities of the James Webb Telescope, astronomers can observe thousands of protostars and young stars at various stages of development in the Carina Nebula. It's fascinating to note that all of these stars form from the same gas cloud, so they share similar compositions and ages. By studying them, scientists can track the entire process of star formation and gain a better understanding of the forces involved. Some stages of this process, which were once only predicted in theory, can take hours or even days to unfold. However, with the James Webb Space Telescope, the chances of capturing these events have greatly improved. Soon, we might even get to see a photo of a young star suddenly lighting up thousands of light-years away from our Sun. Meanwhile, the telescope's 18-section mirror, which spans 6.5 meters in diameter, and its highly precise instruments allow it to capture light from objects that are incredibly far away, right at the edge of the visible universe. These objects are over 13 billion years old, offering us a rare glimpse into the very beginning of time, right after the hypothetical Big Bang. Even with all its power, however, James Webb would not have been able to capture the glow of these distant objects if it weren't for a unique and rare phenomenon: gravitational lensing. This effect, which scientists have known about for a long time, makes it possible to see far deeper into the universe. Here's how it works. When a huge mass, like a galaxy or black hole, exerts a powerful gravitational pull, it bends and magnifies the light from objects behind it. This effect can only happen under very specific conditions, so it is incredibly rare. What makes this discovery even more extraordinary is that while observing the galaxy cluster SMACS 0723, located about 4 billion light-years away from Earth, the James Webb Telescope captured light from a distant object that passed through this gravitational lensing effect not once, but 3 times. This magnified the light by about 20 times, which was crucial because without it, the object's light would have been too faint to detect amid the background noise. Scientists believe that the object in question is an ancient galaxy, approximately 13 billion years old. In addition, the telescope has detected around 10 other star clusters, which are thought to have formed between 200 and 700 million years after the birth of the universe. Some of these clusters appear to have complex structures, which may have taken tens of millions of years to develop. Exoplanets differ greatly in their features and surroundings. Some are extremely large, even bigger than Jupiter, while others are much smaller and more similar in size to Earth. The conditions on these planets can be extreme. Some are very hot with huge oceans of molten lava, while others are completely frozen, covered in layers of permanent ice. Some planets are completely made of oceans with no land at all, while others have strange weather, like rains of sulfuric acid or even snow made of diamonds. To find these faraway worlds, scientists use different methods, as spotting an exoplanet with just a regular telescope is nearly impossible. That's why in 2009, NASA launched the Kepler Space Telescope, specially designed to search for planets outside our solar system. Kepler was equipped with 42 charge-coupled devices, CCDs, which gave it a total resolution of about 96 megapixels. With its wide view, covering about a quarter of the sky, and a mirror with a diameter of 1.4 meters, Kepler could spot planets up to 3,000 light-years away. In the 3.5 years that it worked, Kepler found more than 12,000 possible exoplanets. Of these, over 2,000 have been confirmed through repeated checks. During this time, Kepler also discovered the smallest known exoplanet, Kepler 37b, which is only about a third of the size of Earth. The telescope also helped spot many stars and brown dwarfs, which are objects that are too small to be considered stars, but too large to be planets. Kepler used a method called the transit method to find these exoplanets. This method involves looking for small drops in the brightness of a star. If a planet moves in front of its star, as seen from Earth, it causes the star's light to fade slightly. The amount of fading depends on the sizes of the planet and the star. The regularity of these fading events allows scientists to calculate how long it takes for the planet to orbit its star. The transit method of detecting exoplanets requires accurate measurements. Even small changes in a star's light, often less than 2%, are enough to show the presence of a planet. These changes are usually tiny ripples, often no bigger than 1/10 or even 1/100th of a percent. However, this method is sensitive to interference, especially from Earth's atmosphere, where dust and rain can harm the results. That's why space telescopes are important for finding objects far beyond our solar system, where the atmosphere doesn't get in the way. In 2013, just 3.5 years into its mission, the Kepler Space Telescope faced several major malfunctions. By 2018, the telescope had completely stopped its scientific work. Kepler was the first spacecraft built specifically to search for exoplanets. Despite its groundbreaking work, it mainly discovered distant, faint objects that were too far and dim to study in much detail. This led to the creation of the next generation of space telescopes, designed with different goals in mind. The Kepler mission was followed by the Transiting Exoplanet Survey Satellite, TSS, which NASA launched on April 18, 2018. TESS's main goal was to search for rocky exoplanets orbiting some of the brightest stars within 200 light-years of Earth. Like Kepler, TESS uses the transit method to detect exoplanets. Let's take a quick look at TESS's specifications. It has 4 cameras with a field of view of 24 degrees by 24 degrees, and each camera has a 16.8 megapixel CCD. The spacecraft's special orbit allows it to observe almost the entire sky, around 85% of it, covering both the northern and southern halves. One of TESS's most exciting discoveries was the exoplanet Toei 700d. This planet is the first Earth-sized object found in the habitable zone around its star, where conditions might be right for liquid water. The star it orbits, TOI 700, is a red dwarf located just over 100 light-years away from the Sun. It's a small, cool star with a temperature about half that of the Sun, and its mass and size are just 40% of the Sun's. Interestingly, TOI 700 is a very stable star, having not shown any solar flares since observations began. This stability is important for supporting life, as solar flares can strip planets of their atmospheres, making them less likely to support life. TOI 700 has at least 3 planets orbiting it, one of which is TOI 700b. This planet is roughly the same size as Earth, with a mass about 1.07 times that of Earth and a size that differs by no more than 2%. Unfortunately, TOI 700b is too close to its star, just 0.06 astronomical units away. A year on this planet lasts only 10 days, meaning it's much too hot to support life. The planet TOI 700c is probably tidally locked to its star, meaning it always shows the same side to the star. As a result, one side of the planet could be very hot. TOI 700c is farther from its star than the other 2 planets in the system and is called a mini-Neptune.